Welcome to the Monitoring and Evaluation Technology Expert Series. In this video we're going to be looking at collecting data using mobile devices. I want to introduce a very small example project that we're going to use to explain some of the principles. This is a 5-year program providing soft skills training to young people. Delivered over a series of classes, we train them in different employability skills. The project is aiming to enrol 500 young people over the summer months, and the classes consist of no more than 25 students, and they're delivered right across the region. Our requirement for mobile data collection is that we ask program staff to attend random classes and record trainer and student feedback. So how does mobile data collection work? Initially, you would use an application on your desktop or even online and design the survey and the questions that you need answers for. You will then install the survey on a mobile device, be it a basic mobile phone, a smartphone, or even a tablet computer. These devices are then taken into the field and data is collected. If the device is online, the data can be immediately sent back to the server. However, if it's offline, data can then be sent to the server when it's connected back to the network again. Once all the data has been collected, you can then export that into CSV format for further analysis or storage. So in the data requirements consideration, what has to be collected? If you're collecting anonymous data, then simply go ahead and collect the survey data as described before. However, in our example, we need to know which student has answered which question, so we know where the feedback has come from. A common approach to this problem is within the survey form is to collect unique identifier information. However, a smart data collection solution will allow the surveyor to select the respondent from a list to make sure that the identification is correct and accurate. It doesn't rely on inferred data to make that link. So what does this mean? Well, in our student database, we need to have a unique ID for each student. And then any exported results from our data collection tools must also contain this unique ID. We can then use this unique ID to match the student responses from the survey back to the student database. This can be done, but it's not simple. If we take a further example where we're looking to do a longitudinal survey, where we will run the surveys before and after the training, and then at some time in the longer term, we will potentially collect 3 sets of data through our devices. We need to use this unique ID across all of those data sets to be able to link the student and their responses appropriately, resulting in the large data set. So what are the options you need to consider when looking at mobile data collection? Remote data is the need to collect data out in the field. So your technology must be able to store the data on the device and upload that data when it's connected to the server again. This is not the same as an always-on mobile solution. Instant data is a mobile solution where we're looking to send the data back to the server as soon as it's collected. This means that your device must always be connected in some form. So therefore you need to check if there is electricity and mobile or internet connection in the area where you're collecting your data. If you need to know where the survey has been completed, consider a smartphone solution which can collect the GPS coordinates. However, this may be affected by the surveyor who could collect partial data in the field and then complete all the surveys back at the office, making the GPS coordinates irrelevant. Do you need to collect photographs or videos? If so, you'll need a device which can take photographs, such as a smartphone or a tablet. Could these images be captured in other ways? When selecting the mobile device, functionality is king. You must be mindful of what is essential versus what is nice to have. Do you need to buy new devices, or could you ask the surveyors to use their own mobile phone or tablet computers? How many devices do you need? This really is a budget decision. And what user training is required? Everybody using these devices will need training, but some may need more training than others. You must consider the total cost of the solution. There are plenty of free or open source technology solutions available, but consider the ongoing costs of any technology. What would be the cost associated with changing the initial configuration that you've defined? What about the computers and other devices such as servers and the mobile devices? What costs are you putting in for the data communication charges? And who can actually design and configure the system in the first place? Remember, you might need consultancy, training and support. Be aware of solutions with pay-per-survey, pay-per-device or pay-per-user. The costs will mount up rapidly. There will also be costs associated with the design and implementation stages, especially if you don't have existing staff with the technical skills. So what are the advantages of collecting data in the field? You can collect data anywhere and send it straight back to the server. Data collection can be performed even when you're away from the internet and mobile signals. You can get instant feedback on your program for monitoring purposes and even to provide further support back to your surveyors in the field. Digital data collection in the field will eliminate the storage, transport and data entry costs normally associated with paper surveys. It can also reduce staff training and will result in less data errors. However, what if your surveyors have a problem? Do you have the resources or knowledge to support them? Longitudinal surveys are difficult to link and manage the exported data. It can be done, it tends to be a manual task and it is not trivial. Exported data will only contain the survey answers, and therefore it's difficult to disaggregate and analyse unless a database is used to link responses back to your student database. Mobile technology is expensive and therefore will encounter the common problems of theft. It can also be broken and come over simple technical issues. Remember the battery life. Batteries on tablets and smartphones normally will last one day. Basic mobile phones will last several days on a single charge, so be conscious of where your power sources are going to come from. You must do a cost-benefit analysis to make sure that this approach is appropriate for your situation. If you've got less than 100 students, is it worth it? Don't over-specify. Don't get carried away with the possibilities of what you could do. Only design for what you need. Does the solution need to be connected to the internet or mobile network in order to work? If it does, it will limit the locations where you can collect data. You must decide whether you really need to collect and transmit data when mobile. There are many solutions which allow remote data collection, and the information is uploaded when the device is returned to the office. You must define the roles and responsibilities of all staff involved in the collection, management and analysis of the M&E data. Make sure you define a backup plan. If the technology fails for some reason, consider collecting data on paper until it can be entered into the database. So in summary, mobile data collection allows you to collect data anywhere. It's very easy to assume that everyone has a smartphone. Therefore, beware of following trends or over-specifying your solution. These solutions can be free, but you must consider the total costs of the solution. It can be difficult to reintegrate these results back with your existing database. These are some example mobile data collection solutions. GoProve is a cloud-based, end-to-end solution providing data collection, data management, and built-in analysis and reporting tools. The application offers mobile data collection, both online and offline, and automatically links responses to student records, allowing simple longitudinal survey data collection and analysis.